Alright, first one I'm going to do is the easiest. It is the zero. The zero exponent property. Who's got your calculator out? Okay, well, get your calculator out. No, I want you to do something. What? Yes, it does. I want you to take any number you want to, and I want you to raise it to the zero power. So, here, let me hit record again. Zamora, give me a number, any number. 6. This little button right here that looks like an up arrow, that's how you raise it to an exponent. Raise it to the zero and see what happens.
1.
Yes, you do. Everybody's got that.
Oh, it equals 1.
It equals 1. Zaya, give me another number. Any number.
7.
Zaya. 8. Raise it to the zero power, see what happens.
1.
Do you see a pattern occurring here?
Yeah.
Give me an even harder number that you can...
57.
57. Raised to the zero power. What happens if I make it negative?
Negative 200.
Negative 200 raised to the...
It's negative 1.
Actually, you got to put it in parentheses. Yeah, sorry. Raised to the zero power is... The point that I'm getting at is that any number, anything that you raise to the zero power is 1. Okay? So on your foldable, the zero exponent property, anything to the zero power is 1. Okay? That, except for 0. 0 to the 0 you can't do, but anything else to the zero power is 1.
Really?
Yes, really. Let's put this thing together and do some examples. The very last one is the negative. It's 1. Anything to the zero power is 1. It's just a to the 0 equals 1. Anything to the 0 is 1. All right, negative exponent property. Very last one. Now, negative exponents are bad. We never keep negative exponents, okay? So we need to know what to do with them. If I have, let's say, x to the negative second power, okay? What I have to do is I have to make the exponent positive, but it has to move, okay? And where it moves is to the bottom of the fraction. So x to the negative 2 is the same thing as 1 over x squared. Just flip it. Just flip it and it becomes positive. When it flips over this line, it changes the sign of it. Okay? Yeah, well, you'd keep it where it is. I mean, technically you could, you're just going backwards. You could, this is the same thing as x to the negative 2. What happens then if it's in, let's say I started out, guys, let's say instead of starting out with a negative exponent up top, let's say I started out with 1 over, we'll even say 5 to the negative 3. I can't have a negative exponent, so I make it positive. I cross over that line and I change the sign, so it becomes 5 positive 3 over 1. And we know anything over 1 is just itself, right? Say that one more time. Yep. So let's do a few examples and then we're going to pull everything together and see what happens. All right. Practice makes perfect on these.
Yeah. I mean, I know some people that can actually make me laugh. Y'all make me laugh hard. I do.
That don't have anything to do with exponents. What are you talking about? I said practice makes perfect, and you said yeah, because when y'all make me laugh, it's so funny. Yes, Christian.
Practice is not perfect. Practice is before failure.
Okay. 2/3 to the 0 power. It's 1. The whole thing is raised to the 1. Now, you could think about that property that lets you take it to both if you wanted to. The thing with properties of exponents is there's no order of operations. There's not any one, you don't have to do this property before this property. So when you look at this, if you did 2 to the 0 over 3 to the 0, and you said, hey, anything to the 0 power is 1. What I'm saying is, even if you do the long way like that, you still come back to the same answer, okay?
Also, both of them.
Yep. Both of them's going to be to the 0 power. Well, there's nothing really to distribute to. The base is -8. You turn it into a fraction. So this way, and I need to flip it, right? So I have 1 over. What happens now to that exponent? It becomes positive. What is -8 squared? Positive 64. -8 to the 2nd power. Do it on your calculator. Look. -8 to the 2nd power. How about the pink one? Flip it. What's it become?
2 to the 3rd power over 1.
Which is just
2 to the 3rd power. I still don't have a whole.
It changes to positive when it moves over the division line. I did. That's the same thing. Yeah, that's the same thing. Yep. Let's crank it up a little bit. Crank it back. Now, all properties are on the table to use. You got a whole foldable worth of properties, 7 different properties. I want you to look at it and think about which would be the most feasible to use, which is the easiest, or which one pops out to you first. Christian, what pops out to you first? You say distribute. I'm going to assume you mean multiply.
Yeah, multiply. You gotta multiply the exponents.
I have a power to a power.
Yeah.
Now, some of you might see the negative exponent and want to start flipping around. I would, since I've got 2 negatives there, I would absolutely say, hey, power of a power means to multiply. What's -3 times -1?
3.
Positive 3.
Then you,
That's it. If you want to write it as 125, you can. 5 to the 3rd power is 125. Y'all know they're going to get increasingly harder, so stay with me. Let's do this one. Good job. So, Kamari says you take it to all the things in here, and she is absolutely right. But remember to take it to the 2 also when you do this, okay? What do you know what property that's called?
That is called power from
Power of a yes, it is. Good job. So it's going to go to the 2. It's going to go to the x. But what happens when it goes here? Okay? Why? Why are y'all saying multiply? That's right. When you raise an exponent to another exponent, that means multiply. So that's power of power. So this is 2 to the 3rd, x to the 3rd, y to the what? Good job. Not yet, because negative exponents are... Okay, so here we haven't seen one that's got other stuff in here. The only part that's going to flip, only the piece with the negative moves, okay? Don't move anything else. So the 2 to the 3rd and the x to the 3rd stay, but down on the bottom goes the y and it changes to positive. See how we're using that negative exponent property now? You guess? Let's do another. Oh my goodness, y'all. Yay, Miss McKay, we're doing another one. Christian. Look at this one. This one involves a lot more properties. This is an example of one that we can do different properties at different times, okay? So, looking at this one. So it's 4x. Now here's where I'll warn you, be very careful, because the 4 and the 8 are separate pieces, okay? What do you want to do first? What jumps out at you first? Multiply what?
Can you combine exponents?
Okay, I hear do the bottom one first, and I hear you can only do same base. And so, what do y'all, tell me what to do. Tell me, what happens when you're dividing with, okay, so I heard the y's have the same base.
You subtract them.
You subtract them. Okay, so let's think about this. We've got 4, 8, x negative 2x. What is 4 minus 6?
Negative 2.
Negative 2.
1, negative 2, and you gotta flip it.
Okay? Does that confuse anybody?
Wait, what you just
The only thing I did, what property is this? Quotient of powers. Right? When I divide with the same base, then I subtract. Okay? What do you see now that you want to do? I subtracted 4 minus 6 is negative 2. Every time you subtract, it stays in the top. Even if it's negative. Yep, look. 4 minus 6. Top minus bottom every time. Mm-hmm. Yep. All right. No, that's okay. All right. I heard negative exponents.
Yeah.
Okay. I'm going to take this one and this one since they're both negative, and I'm going to move them down over the line to make them positive, okay? So what is still in the top? 4. Now in the bottom, 8x was already there, right?
Yeah.
Now I'm going to have also x positive, change the sign when it moves over the line, and y 2. Change the sign over the line.
Please stop.
All right, so yes, Kennedy, yours. All right, this was negative exponent. Negative exponent. And Kennedy says, but wait, we have two x's in the bottom, and she's absolutely right. I have two values here that have the same base. You add them. But I don't see an exponent on this one.
It's a 1.
It's a 1. Good job. So I have 4, 8, now it's x3, y2. That was called product of powers. No, that's a slip with mine. 1 plus 2.
Equals 3.
These two, come on. These two came together to make the x3. Now, there's one more thing that we can do that we haven't talked about a whole lot, and it's not a property of exponent, but it's just a simplification technique. What is 4 divided by 8? No, 8 divided by 4 is 2. Okay, so if you had this as a fraction, if you had the fraction 4 over 8, how could you simplify it? Even bigger.
4.
What's left on top? 1. What's left on the bottom? 2. And then the variables are the same. I just simplified the fraction that sits in front. Yeah, you do. Uno más. Let's do a hard one.
Okay, yeah.
Write this one down because it still must be included in your homework. This is number 43 from your homework. This is number 43, and this is the hardest one on your homework, in my opinion. And we're going to do it together. Just because there's so many properties embedded in this problem. Worked into it. You're right, though. But when I see that parenthesis with an exponent outside, I want to go ahead and distribute that exponent, okay? Distribute. All right. So I have the top stays the same, right? But on the bottom, the 4 gets a 2. The x negative 2 gets a 2. Everybody gets a 2. The y negative 6 gets a 2. You ever seen Oprah when she's going to, you get a car and you get a car? No, that's exactly right. That's exactly right. Now I have to multiply them. So up top, and I'm not even messing with the top right now. I'm going to try to get the bottom where I can work with it. And then, all right, 4 to the second is 16. Negative 2 times negative 2.
Why do you have 16 up there?
4 to the second.
Yeah.
Oh, I didn't know we saw that too.
You can.
Just because I'm going to simplify the numbers in front, so I want to try to get those nice and neat. What is negative 2 times negative 2? Positive 4. Good job, Zai. Negative 6 times 2. Close. Negative 12. Now it's up to you what we do next. Do you want to move negatives? Do you want to subtract? It depends. You can't leave it like that. Go ahead, Zamori. Go ahead. Tell them what to do.
That'll be negative 7 minus negative 12. That'll be y.
All right, Christian says let's subtract the exponents on the y's.
Yes.
So negative 7 minus negative 12. I would maybe use the calculator if you don't understand. Look, negative 7 minus negative 12. Always subtract when you divide. It's 5. You're absolutely right. Okay? I've still got 16 and I've still got x4.
Oh, you subtract 8 of That'd be 4.
Subtract what? What are you subtracting? The x's?
X's.
Okay.
4.
8 minus 4
It's
is 4. Y5 is still there. 16 still in the bottom.
Divide.
okay, divide.
Divide by what?
2.
So do we
6.
simplify it or do we
4.
Golly, just keep shouting numbers. You'll get there eventually. It was 4, but my goodness.
This is easy.
Yes, ma'am.
Simplify.
Yes, you're going to simplify these numbers in front. That's what he was saying. Divide it by, and he was guessing every number, but they're both divisible by 4.
So before,
So it'd be, what's 12 divided by 4? 3.
X.
over 4.
4. Y. 5.
That's right, it's more over 4. Now it's simplified.
We done.
How do you know when it's simplified?
You can't divide
We
anything.
can't, yeah, we can't do
You can't divide the numbers by
You
anything.
can't subtract or multiply.
There are no negative
The
exponents,
bases are different.
and you only have one of each base.
Ooh, that was a lot of work.